Okay guys, good morning. So today we're going to take our previous lesson a little bit further and we're going to multiply monomials, right? So we'll talk about a little bit what a monomial is. But first let's review what we did yesterday. So yesterday we said when we were multiplying powers of the same base, we're going to keep the base and add the power. So if I keep the base of a and I add the exponents, 5 plus -4 is 1. So I can just leave it as a, or a to the first. For the second one, we're just going to do a little review of a negative exponent. So a to the -7th is 1 divided by a to the 7th. For number 3, I have a whole bunch of powers of y. So I'm going to write in the ones where I don't see a power. And then I'm going to add. So 1 plus 2 plus 1 is 4, plus -10 is -6. And y to the -6th is 1 divided by y to the 6th. For number 4, I've got 5 to the 4th times 5 to the 1st is 5 to the 5th. 7 to the 6th times 7 to the -3rd is 7 to the 3rd. For number 5, a to the 7th times a to the -7th is a to the 0. b to the -4th times b to the 5th is b to the 1st. Since a to the 0 power is equal to 1, my answer is simply b. For number 6, I've got 2 to the 7th times 8. Now we should know 8 is equal to 2 times 2 times 2, which is 2 cubed. So I end up with 2 to the 7th times 2 cubed, which will end up with 2 to the 10th. And for the next one, this one's pretty hard, right? So 9 to the 4th. So that's really 9 times 9 times 9 times 9. Now each of those 9s is 3 times 3, so you can probably predict that we will have 8 of these 3s. Right, each of my 9s being 3 times 3. So I've got 3 to the 5th times 3 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 times 3. That's another 8 powers of 3. So 3 to the 5th times 3 to the 8th altogether is going to give me 3 to the 13th, because that's how many powers of 3 I will have. Each of those 9s is 2 3s, so 4 9s is 4 times 2, which is 8, plus the other 5 is 13. So let's start to talk about a monomial. Okay? So a monomial, or what we call a term, can be a number, it could be a variable, or it could be a combination, right? So a monomial could be 3, it could be 3x, it could be 3x to the 5th, it could be 3x squared, y to the 4th, z to the 10th. Now if we have 3x plus 2, well that doesn't work, that's a binomial. All right, so just as far as the vocabulary, a monomial is just one term. Okay, so how can we multiply these things? Well, let's start by breaking them down. So 6x squared is 6 times x squared, which is x times x. And 3x to the 5th is 3 times x, 5 powers of x. Well, what can I do? Well, I know that 6 times 3 is 18. And I know that if I count up all those powers of x, 1, 2, 3, 4, 5, 6, 7, that I've got x to the 7th. All right, well, I don't really feel like doing this every time, especially if those exponents are a little bit bigger. So let's talk about the two things that we did. Well, one, I multiplied the coefficients, which were 6 and 3. And 2, I added the powers of x, or more specifically, add powers of the same base. All right, so again, what did we do? We multiplied the coefficients, right? The coefficients are the numbers that are being multiplied by the variables, 6 and 3. And then we added the powers of the same base. I said 2 plus 5 was 7. Pretty simple procedure. So I'm going to go through some of these pretty quick because I've got a lot of examples in this lesson. So anything you need to slow down, you just pause it and go back. All right, so here, pretty simple, right? Multiply the coefficients. 4 times 6 is 24. Add the powers of y. 3 plus 4 is 7. Multiply the coefficients. 8 times 5 is 40. Add the powers of v to the 7th. Multiply the coefficients. 3 times 1 times 1 is 3. Add the powers of a. 3 plus 2 plus 3 is 8. Same thing with some negatives. Multiply the coefficients. 7 times negative 3 is negative 21. Add the powers of y. 9 plus negative 3 is 6. Multiply the coefficients. Negative 2 times negative 1 times negative 1 should give us negative 2. And if I add the powers of a, 4 plus 1 plus 11 is 16. Negative 12 times 2 is negative 24 times negative 1 is positive 24. And if I add the powers of a, 10 plus negative 5 plus 4 should give me 8 to the 9th. Find the missing monomial, right? So 5y to the 9th times something is going to give us 30y to the 12th. So 5 times what gives me 30 times 6. I've got 9 powers of y. I want to get up to 12 powers of y. I need to use 3 powers of y. How about with the next one? Well, negative 6 times what will give me positive 18 times negative 3. And I've got negative 3 powers of y. I want to get all the way up to 4 powers of y. I would need to add 7, so negative 3y to the 7th. Okay, guys, so there's your now try. So you're going to pause, and then we'll come back and share. So 5 times 6 is 30, and when I add the powers of y, we end up with y to the 5th. 8 times 2 is 16. And when I add the powers of a, negative 3 plus 7 is 4. Let's see how we did with this one. So 2 times negative 5 is negative 10. 6 plus negative 6 is 0. Now, we would have a really good discussion about this in class. Is the answer 1? And the answer is it's not 1, because negative 10 is not raised to the 0. There's no parentheses around. In other words, if we had something like this, the whole thing is raised to the 0. That would be 1. Only the y is being raised to the 0. So this is negative 10 times y to the 0, which is negative 10 times 1, which is simply negative 10. For the next one, I'm going to multiply all my coefficients. Negative 4 times 1 times negative 6, which is 24. I'm going to add my powers of a. 6 plus 3 plus 5 is 14. All right, now for this one, I got my product, right? So negative 5 times what gives me negative 45, 9. And I've got negative 2 powers of y. I want to get all the way down to negative 10, so I need to use negative 8. Because when I multiply negative 5 times 9, it gives me negative 45. When I add negative 2 plus negative 8, it gives me negative 10. Now the second part of the lesson involves what happens if there's different variables, all right? So the rule really is going to be the same. We're not going to rewrite the rule. What happens here? Well, I've got 5 times 3 is 15. Well, I've got 2 powers of x and I've got 6 powers of y. That's not going to change. I'm not going to add those together. In other words, I've got 5 times x times 3 times 6 powers of y. I don't have 8 powers of anything. I have 5 times 3 is 15. And I've still got 2 powers of x, and I've still got 6 powers of y. Well, what happens here? Well, I can multiply 3 times 4 is 12, but I've also got x squared times x to the 5th, which I already know is x to the 7th, and I've got y squared times y cubed, which I know is going to be y to the 5th. So what is our rule? It's exactly the same. Multiply the coefficients and add the powers of the common variable. So if the variables are not the same, you leave that part as is, you just multiply the coefficients. So that's what we see with this first one, right? 3 times 6 is 18, and I've still got 4 powers of x, and I've still got 3 powers of y. Negative 7 times negative 5 is 35. I've still got 4 powers of a. I've still got 6 powers of b. 3 times 5 is 15 times negative 2 is negative 30. I've still got 3 powers of A, I've still got 5 powers of B, and 2 powers of C. Do you need to write the variables the way I am? Well, in general, when we write expressions, we write them in alphabetical order, okay? So if you wrote a to the 3rd, c squared, b to the 5th, you're not wrong. Mathematically, it's all multiplication, so it all means the same. We want to get into the habit of writing them in alphabetical order. So if somebody said, well, what if I've got y to the 4th, z to the 5th, x squared, I would write that as x squared, y to the 4th, z to the 5th. I'm not changing the exponents, of course, but I'm just changing the order in which I write them. All right, now we've got both variables, right? So 3 times 9 is 27. X squared times x to the fourth, we add the powers. X cubed times y cubed times y to the fourth, we add the powers. How about down here? Negative 2 times negative 5 is 10. I'll add my powers of A. I'll add my powers of B. 1 times 5 times negative 2 is negative 10. I add up all my powers of A. I add up all my powers of B. All right, 4 times 7 is 28. I add up my powers of x. I add up my powers of y. Since x to the 0 is equal to 1, I simply end up with 28y squared. All right, negative 12 times negative 5 is 60. Add my powers of a, that's a to the first. Add my powers to b, that's b to the negative eighth. I'm okay with you leaving it like this, but if you want to write it as a fraction, since only the b is being raised to the negative eighth, that's all that needs to drop to our denominator. And again, guys, I realize I'm going through this kind of quickly because we did have so many examples. Just make sure you go back or you pause after every example so that you can get some notes. Find the missing monomial. So 4 times what will give me 28 times 7. X squared times what will give me x to the 7th, x to the 5th. Y cubed times what will give me y to the 10th, y to the 7th. Negative 12 times what will give me 60 times negative 5. A cubed times what will give me a to the negative 2nd. Well, that would be a to the negative 5th. And from b to the negative 5th, to get all the way up to b to the 7th, I have to use b to the 12th. All right, guys, so there is your now try. All right, so for the first one, we multiply the coefficients. We have different variables, so we keep x to the 3rd, we keep y to the 8th. For the next one, I'm going to multiply my coefficients. I'm going to add my powers of a. I'm going to add my powers of b. I'm going to multiply my coefficients. I'm going to add my powers of x. I'm going to add my powers of y. And if you want to go a little bit further, only the x to the negative 3rd would get dropped to the denominator and we make the power positive. For number 4, I'm going to bring that one down here. I multiply my coefficients. A to the negative 4th times a to the 4th should be a to the 0. B to the 5th times b squared is b to the 7th, and then c to the 9th. Now, since only a is being raised to the 0 power, that's all that becomes 1. For number 5, we just have some fractions, right? So we've got, this one actually turns out to be kind of hard. So 1/2 times negative 3/4 is negative 3/8. X to the negative 2nd times x to the 1st is x to the negative 1st, and then y to the 9th. So this actually, if you wanted to write this as a fraction, what happens is you get negative 3/8. X to the negative 1st is 1 divided by x to the 1st, and then times y to the 9th. So you actually end up with negative 3y to the 9th divided by 8x. So that's a pretty tricky one. And then 6 really isn't so bad, right? 10 times what gives me negative 40 times negative 4. I've got a to a squared is just a. B to the negative 3rd to b to the negative 3rd, I don't need to put anything there. I don't want to change it at all. So if I multiply by negative 4a, I get negative 40, a to the 2nd, and then b to the negative 3rd stays the same. All right, guys, there is your homework. Pretty straightforward. I didn't give you any of the really terribly difficult ones. So you're going to write out the problem, and then you can write out the answer next to it or underneath it. Any questions, comments, or concerns, upload your work and post a comment on Google Classroom.